First question, a horizontal force of 5 Newton is required to maintain a velocity of 2 meter per second for a block of 10 kg mass gliding over a rough surface. The work done by this force in 1 minute is what? So we are supposed to find out the work done. Okay, so we know what all things are given. We know force is given, that is 5 Newton. We know velocity is given, that is 2 meter per second. And we also know the mass is given, that is 10 kg. Also, we know that it is work done by this force in 1 minute. So we know the time also, that it is 1 minute. That means it is equal to 60 seconds. Now, the formula for the work done is equals to force into displacement. We can put displacement is equals to velocity into time. That is force into velocity into time. Substituting the values, force is 5, velocity given is 2 meter per second, and the time required is 60 seconds. Doing this calculation, we get the answer as 600, and the unit for work done is joule. Looking towards the option, we have 600 joule in option A, and thus the correct answer among the given option is option A. Looking towards the next question, what is the shape of the graph between the speed and kinetic energy of a body? Will it be straight line, hyperbola, parabola, or exponential? So kinetic energy, we know the formula that kinetic energy is equals to half mv square. That means that kinetic energy is directly proportional to velocity square. It means the graph between the speed, that is this velocity, and kinetic energy will be parabolic in nature. So the correct answer among the given option is parabola. And the graph obtained between the speed, that is velocity, and kinetic energy of a body attains a shape of parabola. Looking towards the next question, the energy required to accelerate a car from 10 meter per second to 20 meter per second is how many times the energy required to accelerate the car from rest to 10 meter per second. Now here this is the first condition and this is the second condition. So we'll find out the energy, that is nothing but the kinetic energy. So kinetic energy for the first condition is equals to half m v square, but here we have the change in velocity, so it would be v2 square minus v1 square. Okay, let's put the value, that is half, we don't know the mass, so we'll put it as it is. Then the velocity is given, so this is v2 and this is v1, so it is 20 square minus 10 square, and it comes out to be 150. This m as it is 150 m, and the unit will be joule. Looking towards the another condition, that is the kinetic energy for the second condition, we'll take the formula as it is half m v2 square minus v1 square, which is equals to half into mass we don't know, but the velocity is v2 is 10 and v1 is 0. So it's 10 square minus 0 square, and this answer comes out to be 50 m, and the unit is joule. So we get the first condition ka kinetic energy and the second condition kinetic energy. Now we are supposed to relate these two, that is kinetic energy for the first condition upon kinetic energy for the second condition, that is 150 upon 50, and its fraction comes out to be 3. So kinetic energy 1 is equals to 3 into kinetic energy for the second condition. So it's 3 times. Okay, so the correct answer among the given option is option D. Looking towards the next question. A body of mass m1 moving with uniform velocity of 40 meter per second collides with another mass m2 at rest, and then the two together begins to move with uniform velocity of 30 meter per second. The ratio of their masses m1 and m2 is. So here we know that there's one body of mass m1 and it is moving with a speed of 40 meter per second, and there is one body of mass m2 which is at rest. Further, they are going to combine together and make a new body because they are going to move together. Then the two together begin to move with uniform velocity. So this body will be having m1 plus m2, and this body is moving with a constant or the uniform velocity of 30 meter per second. Now the initial momentum, okay, so we'll find out the initial condition momentum. So that is m1 v1. So m1 is as it is, v1 is given, that is 40, plus m2 is given, m2 will write as it is, and the velocity is 0. So this comes out to be, okay, but this will keep as it is. Then we'll look for the final momentum, that is for the second condition. Here it is m1 plus m2 multiplied by velocity, that is 30 meter per second. Now, by the law of conservation of momentum, we know that the two should be equal. So we'll take it consideration by the law of conservation of momentum. m1 into 40 plus m2 into 0, which is equal to m1 plus m2 into 30. Now we need to solve it out. So m2 into 0 will become 0. So this side we have only 40 m1, and this side we have 30 m1 plus 30 m2. We'll take m1 on this side, so it will become 40 m1 minus 30 m1, which is equal to 30 m2. When you subtract it, we get 10 m1, which is equal to 30 m2, and to take the ratio, I can say m1 upon m2 is equal to 30 upon 10, which is nothing but equal to 3. So this is the ratio. We are supposed to find out in the question the ratio of their masses m1 and m2, and its ratio comes out to be 3. Now looking towards the option, we have 3 in option C. So the correct answer for this question is option C. Looking towards the last question, that is, when a body moves with some friction on a surface, either it will lose kinetic energy but momentum is constant, or it will lose kinetic energy but gains potential energy, or the kinetic energy and the momentum both will decrease, or the mechanical energy is conserved. So when friction, or basically we know that friction is non-conservative external force to the system. It decreases momentum and kinetic energy both. So while friction, kinetic energy will decrease as well as momentum will going to decrease. So now looking at the option, which is the correct one, is option C, that is kinetic energy and momentum both will going to decrease. So correct answer among the given option is option C.